Hello everyone, me, your friend Krishna Kumar Chaudhary came with the content. Today's content is that is Cauchy mean value theorem. Okay, Cauchy mean value theorem. Value theorem. Earlier we have discussed in the previous classes. Our content was Lagrange's mean value theorem, and it was for the single functions. Now Cauchy mean value theorem, if there will be the two functions, no more than one, that is two functions. If fx and gx are two functions, suppose we have two functions. For single function we do have Lagrange's mean value theorem. For two functions we have Cauchy mean value. Two functions, no, two functions which are, the condition is, which are, first condition is continuous in that closed interval AB. Okay, continuous in closed interval AB. And second condition, you have differentiable in AB. No, if both the functions are, earlier we have single function continuous in AB, differentiable in AB. For the single function we do have Lagrange's mean value theorem. Now for the, if there is function, two functions are there, then we do have the Cauchy mean value theorem, and it states that if fx and gx are two functions, suppose two functions are fx gx, both are continuous and differentiable in AB, then there exists at least one value, then there exists at least one value, you can say, or one point, you can say one point C, that C will belongs to AB, means C will lies in between A and B, anywhere. C belongs to AB such that it will lie in such a way such that f dash C and by g dash C, okay, that is FB minus FA and by GB minus GA will be, no, where g dash C should not be equal to 0, no, in AB. This is the conditions. This is the statement of the Cauchy mean value theorem. Now, Cauchy mean value theorem states that if two functions are there, suppose fx and gs are two functions that are continuous on closed interval AB and differentiable in open interval AB, then we will find a value, one point between A and C, anywhere within A and C, A and B. The point is, say that point is C, and it will be such type of point that will be the derivative of first function f dash at that point, and ratio of f dash C by g dash C, that will be equal to the ratio of what, in points of the functional value, okay, of respective functions. Okay, now let's come to the proof. For the proof, we will take the help of Rolle's theorems. And Rolle's theorem, we know that Rolle's theorem condition, that should be the continuous, that should be the differentiable, and functional value at the in points will be equal, then there will be the one point C, such way f dash C equal to 0 will be, no, or that derivative at that point will be the 0. So we will take the help of Rolle's theorem. To take the help of Rolle's theorem, we will define a new function. Let us define a new function. Let us define a new functions. Okay, new functions. The function is such type. Suppose that new function is capital Fx, and function you have defined in a such a way that denominator into Fx, okay, GB minus GA into Fx, then minus numerator, that is FB minus FA, then gx. You have defined a new functions. Now to apply for this new functions Rolle's theorems, obviously you should have the function. This new function should be continuous, new function should be differentiable, new function should be fa is equal to fb should be there, no, and then we can apply the Rolle's theorem. Okay, so this function this function means what? Capital Fx, new function, is continuous in that closed interval. Why? Because since both fx and gx are continuous, since fx and gx are continuous, fx and gx are continuous in AB, no, and obviously fx and gx are continuous, then subtraction of the continuous function will be the continuous, so this new function become continuous. Now next step is according to Rolle's theorem, that continuous you have showed. Now next step is for differentiability, no. So for differentiability, obviously you will find the derivative of this f dash x. What will be the f dash x? You will get gb minus ga, and then f dash x minus, and then fb minus fa, and derivative of this function will be the g dash x, no. And this function means new function fx is differentiable, no. Why it is differentiable? Differentiable in AB. Why? Because since this fx and gx are differentiable, fx and gx are differentiable, no. Due to this reason, the new function that fx is your differentiable. Now your target is to show what? Fa is equal to fb, no. So find fa, no. After then your target is here fa, you need to find here fa, here capital fa. Just substitute wherever you have x, substitute in this x. Okay, instead of x you will substitute a. Okay, so you will substitute here a, and you will substitute here, what you will get? Fa is equal to obviously gb minus ga. Okay, and then fa minus, then what you have? fb minus fa, and then ga, no. Just product it. What you will get? You will get fa gb minus fa ga, and then just we can multiply with minus, and this ga, what will you? Minus fb ga, and then minus plus fa ga, no. This you got. So which will be the cancel? Obviously fag and fga will be cancelled, remaining will be your small fa gb minus fb ga. This you got fa, capital Fa, new function. And similarly calculate the fb. What you will get? Just substitute, instead of x you need to substitute b, gb minus ga, and then fb minus, and then you have here fb minus fa, and lastly you have gb, no. So calculate it. fb gb minus fb ga, and minus product it, then fb gb, and then plus fa gb, no. Which will be the cancel? Obviously fb gb and fb gb will cancel, then fb, what you will get? You will get small fa gb minus fb g. What you found? And what you find? Obviously you found fa is equal to fb. You found, no. You found fa is equal to fb. Now you can apply the Rolle's theorem. Then by Rolle's theorem there exists there exists C belongs to A, B. C will lies between A and B in such a way such that what you are working for the capital F new function, so f dash C is equal to 0. This you have the condition of the Rolle's theorem. Then what you have f dash x, what you have in the obviously you have a new function f dash x is this much. No, just f dash C, what you will get, obviously instead of x you will substitute a C, then you will get this one, right side one, just keep the values, what you will get, then you will get or GB minus GA of f dash C, and then minus FB, okay, FB minus FA, and then what, G dash C is equal to 0. Just take this another side, then what you will get, GB minus GA inside the bracket, and you have here f dash C which is equal to FB minus FA and product with G dash C. So therefore what you got, f dash C, and by G dash C obviously will get what, FB minus FA and by GB minus GA. This is your Rolle's, this is your Cauchy mean value theorem. No, this is your problem. Okay, now let's take one problem. Okay, one problem we can take for the verification. So this is your Cauchy mean value theorem. Let's take the problem. One question we can take. Question is what? Verify Cauchy mean value theorem. Cauchy mean value theorem. Cauchy mean value theorem for the function functions fx equal to x and then gx is equal to x square in minus 2 comma 0. No, minus 2 comma 0. So what will be the solution for this? Obviously to verify Cauchy mean value theorem you need to have first both the function continuous, both the function differentiable, and that point should lie one of the point between, if you will take that point will lie between the minus 2 and 0 should be lied. Okay, so for that what the function for continuity, obviously you will check for the continuity you need to check it. No, continuity what, for the functions fx equal to x and gx is equal to x square are continuous in minus 2 comma 0. Why it is so? Because since fx and gx are polynomial function, due to this reason the function is continuous. No, and we know that polynomial functions are being always continuous, so the function is continuous. Now obviously you will need to check the differentiability. You need to check, and for that obviously you will find what, f dash x you will find. Then if you will find the f dash x, then you will get 1, and g dash x what you will get, obviously you will get 2. The functions are differentiable, both are differentiable in minus 2 comma 0. Why? Because if you will after differentiation, if you will substitute all the values between minus 2 and 0, obviously it will exist for both the functions, so the function is differentiable. Now you will take what, one value, particular value, say that value is c, then by Cauchy mean value theorem, there exists a point. You will take a point, one point, say c, okay, between minus 2 and 0, such that you need to check that point will lie between this or not, such that no, such that f dash c and by g dash c is equal to what? Fb minus fa and by gb minus ga. For what function? For that should be the between a and b, no, for ab. And for if you will take for minus 2 0, what you will get? Minus 2 0 if you will take, obviously you will get f dash c and by g dash c, no, which is equal to f minus f0, no, right, f0 minus f minus 2, and then you will have g0 minus g minus 2, no, this is okay. Now what is your target? Your target is to find the value of c, and that value should lies within this. Okay, so for this obviously f dash c, what you have, I will take here of, no, I will take here of this side, f dash x you have what? 1. Then what you will get? F dash c, obviously you will get 1, so 1 by, and then g dash c, g dash x, what you have? G dash x you have 2c, 2x. Then what will be the g dash c? Obviously you will get 2c, so 2c you will have here, no, 1 by 2c. And f0, fx, what you have? Fx you have ax. Then what will be the f0? Obviously you will get 0, so 0 minus f minus 2, if you will substitute minus 2 here instead of x, obviously you will get minus 2, then you will have here minus 2. And by gx, what you have? Gx you have x square. Then what we will get? G0, obviously you will get 0 minus, and g minus 2, what you will get? G minus 2, obviously you will get 4, so 4, no, this. So 1 by 2c is equal to 2 by minus 4 you will get, then 4c is equal to minus 4, so c you will got how much? 1. And this one you check it whether it will lie, obviously minus, between minus 2 and 0, this minus 1 will lie within this minus 2, hence Cauchy mean value theorem verified. Cauchy mean value theorem verified. Theorem verified, no, verified. If you would find that it will not lie within this, then obviously it will not be verified. Or if you would got that differentiable does not exist, then it would not be verified. If you would get continuity, obviously any one of the function is not continuous, then again that Cauchy mean value theorem is not verified. Okay, that will be the concept. Okay, thank you this much for today. Any of the queries, then you can ask in my messenger. Thank you.